So we all know that matter is something or a substance which can occupy space and have mass. Mass plus space is important for any matter. Okay. Then we have studied the classification of matter as well, where we got to know that matter can be classified into two: physical and chemical properties, according to their physical and chemical properties, right? Then we further studied about also we have studied about weight and mass as well. We have done its differences also, that mass remain constant irrespective to the location, but weight start differing in the specific location. Also, we know that this mass is what? Mass is the measurement of matter, right? Present inside the or composition of matter present in any sort of substance, right? And weight we have done that it's a force, right? And which is applied to the object due to gravity, right? We have done this one. What else we done? Yeah. Then we have done the physical properties of matter. Now, who will tell me how many physical properties we have discussed yesterday? Then I'll ask one question and then we move further. How many physical properties we have discussed? Number one was what? With an experiment, we have seen this experiment of potassium permanganate we have taken, and this experiment proved that, who will tell me? Anyone want to volunteer for this question? Potassium permanganate experiment. Yesterday we have done this, right? What does this experiment prove to us? Which physical property we have learned through this experiment? What happens, students? You don't remember or you don't want to answer? So we have learned that particles present inside the matter are known as atom, which are very small and in infinite number. Right? We have learned this yesterday. Now, who will tell me the second one? Is the class boring, students? Come on, the second one. Second physical property. Am I audible to you all? Okay, tell me if I'm audible to you or not. Everyone. Okay, Lipika, thank you for confirmation. So the next property we have learned yesterday was that these particles or these atoms which are present in different states of matter has space in between them, right? They have some space, right? So in this way, which was related to the second property, there was a third property also which state that every particles present inside the matter shows what? Movement, shows random movement, right? And this random movement is directly proportional to what? Least random movement is directly proportional to kinetic energy, and kinetic energy is directly proportional to diffusion. Diffusion means mixing up of fluids, gases, or anything, or any substance or solute into solvent. So this is known as diffusion, or movement of gases from higher concentration to lower concentration. So all this we have covered yesterday. Particles of matter have space between them. Okay, Lavanya. Okay, now I will ask one question. Okay. So my question is, why does diffusion happen faster at higher temperature? Does diffusion has any relationship with the temperature, students? Is there any relationship of diffusion with respect to temperature? If we increase the temperature, does the diffusion also raises up? And if it does, so why does that happen? Okay, Om. So would you like to explain the answer? Why does diffusion happen faster at higher temperature? What happen when we increase the temperature? Increase the temperature means heat only. Cause more space between the molecules. But before that, Lipika, don't you think the particles start moving more increasingly, like kinetic energy increases? Like if we start giving high temperature to the solids, solid particles are so much bonded with each other. But the moment we started applying high temperature to the solid, they start moving randomly. And yes, then they will have more space between the molecules and it will lead to the change of phases. Like solid will turn into liquid, right? Okay, so one more question. Why can a CNG cylinder store gas at higher pressure? Why can a CNG cylinder store gas at higher pressure? So these questions can be asked in your question papers because in this chapter there is nothing but they will ask you reasons. Statement questions are there. So if you want to write the question, go on, write those questions. But also give answers also. Okay, so the question is, why can a CNG cylinder store gas at higher pressure? Why can a CNG cylinder store gas at higher pressure? Does it related to the movement of gases, movement of particles present inside the gas? And if it does depend upon the particles movement, so what is the property which is making? Repeat the question once again. Why can a CNG, okay, I'll write it down. Why can a CNG cylinder store gas at high pressure? So this is the question. Actually, answer is there in this word itself, if you know the full form. CNG is what, students? What is CNG stands for? Anyone? So CNG stands for, yes, compressed natural gas. So it itself says that we can compress the gas easily at higher pressure inside the cylinders. So this is the answer because the particles of gases are having so much space in between them, right? So we can easily compress the gas inside the cylinder at higher pressure. So this is going to be the answer for this question. One more question and then we are going to move forward. Okay. The smell of, okay, I'm going to write this one. So the next question is,
Excuse me, ma'am.
yes, Lavanya, your voice is breaking. Tell me, Lavanya.
Ma'am, I have network issue. Can you tell? Excuse me, ma'am.
Lavanya, your voice is breaking. I'm not able to hear you. Can you just write your question in the chat box? Hope you can hear me.
Me.
Lavanya, just write your question in the chat box because I'm not able to hear you actually. Okay, so the last question is, why the smell of hot food spread faster than the cold or the warm food? Who is going to give this answer? Why the smell of hot food spread faster than the cold or warm food? I want the answer, students. Please give me the answer. Otherwise, I will think you're not able to understand these concepts. And there must be a scientific term and word which you have learnt already, okay? In your statement answer. But one answer is here. Anybody else? Why does the hot food smell spread faster than the hot and the warm food? Don't know. Because of vapors, okay. Don't know. Okay. See, students, we already know, no? Hot food, when we are cooking the food, actually we are doing what? Increasing the temperature. So when we increase the temperature, kinetic energy will increase. When kinetic energy will increase, then diffusion of those gas particles will be more and they will spread like increasingly, speedily in the environment. So that is why we are easy to, like it is easy to smell the hot food in comparison to cold and the warm food because we are applying temperature to the food.
Ma'am, can you hear me now?
Yes, I am able to hear you, Lavanya. Tell me.
Ma'am, can you tell me the answer of the CNG1 question?
Yes, sure. So in the CNG one, that we have mentioned that because it is due to, you already know the name of the CNG, compressed natural gas, we are able to compress the gas inside the cylinders at high pressure. That is why we are able to compress the gas particles inside the cylinder at high pressure.
Okay, ma'am.
Okay. Hmm. And this one, so Mehak, I think you are giving the answer. Okay, Lipika. Hot food vapor have more space between them than the cold food. All right, I got it, Lipika. Kinetic energy, yes, but you need to mention diffusion as well. Diffusion is faster. You need to mention this term, diffusion. That is why, when we are increasing the temperature, kinetic energy will increase in the particles, and that is increasing the diffusion of that particles inside the environment, around the environment. That helps to smell the food easily. So diffusion, the main term, you need to include that one. Okay, everyone, do you have any doubt in this question? Shall we proceed further? Lipika and Mehak and other students?
Yes, ma'am.
Tell me. Done? Lavanya, do you have any doubt in this
No,
question?
ma'am.
Okay. So we will proceed further. 3 properties we have already done, and now it's time to know the 4th property of matter. Okay. This we have done. They are in continuous movement. Now, there is a concept known as Brownian motion. Have you ever heard about it? Or you might have observed this one, Brownian motion. It is actually an experiment, students, which was done by Robert Brown. That experiment we will discuss that experiment later on. But for now, just know that Brownian motion is the experiment which help us to prove that particles are in movement inside the fluid or in the environment or in the gases. Got it? So the best evidence for the existence and movement of particles in liquids can be explained by Brownian motion. See, Robert Brown. Robert Brown is a famous scientist. If you have know the discovery of Robert Brown, any familiar discovery students about Robert Brown? Very famous study. Have you you people have studied this chapter cell? Maybe.
Yes,
So
ma'am.
in that chapter, you must have heard about Robert Brown. He was the first scientist who has discovered the cells through the wooden cork, right? Through the piece of cork. But he has discovered the dead cells. Okay, so Robert Brown is the same scientist who had discovered this Brownian motion as well. And the experiment we will now discuss the experiment. He suspended extremely small pollen grains in water. So students, what are pollen grains? Pollen grains, Anybody? Okay. Have you heard about pollination, students? Pollination. In the bark of tree, he discovered. Yes, Fauzan. In the wooden cork, which was a dead cells, we got it. But now I'm asking, have you heard about pollen grains or pollens or pollination? Students, there are certain pollutants in our environment. So what does they do? No, for example, the during the windy time, when the environment is full of stormy, then you must have seen some sort of you must have seen this. It looks like a cotton structure, like this, which are keep on moving inside the wind or the storms here and there. You have seen this particles moving, especially during the stormy or the windy time. These are actually the pollens. Now, pollens are the one which will help the flower to bloom. Okay? You must have studied about reproduction of a plant or a flower. So, pollens are actually uh, placed on the flower, and they will go down and they will form the seed, and that seed will generate the whole fruit. So pollens are the one which are moving here and there, and some pollutants like birds or some insects which can take the or transfer these pollens from one flower to another flower. So this sort of pollen was taken by Robert Brown and he put this pollen grain inside the water. Now he observed that each particles of this pollen grains started scattering, spreading inside the fluid. Why so? Why does that happen? Why does these particles keep on spreading inside the fluid? Anyone? You can see under the microscope, he found that the pollen grains were moving rapidly throughout water in a zigzag way. The pollen grains move the space between them, male part of the flower. Yes, yes. Male part is actually anther and filament. So it is a part which is protruding outside, like it is coming out. Gamete, you can say. Okay, which is required for the fertilization. Okay, leave that part. That is biology. See this experiment. So that pollen grain was immersed inside the water, and he observed that he found that the pollen grains were moving rapidly throughout water in zigzag way. The pollen grains move on the surface of water because they are constantly moving or being hit by the fast moving particles of water. So Brownian motion states that or prove that the movement of particles inside the fluid due to the collision of other particles which are actually present inside that solvent or around us. You know, the air also shows the Brownian motion or gases. You must have observed, students, when during the afternoon time, no, when you kept your window closed and there are like all the curtains are present on the window, then when from a small hole there you can see a dust particles, like particles of dust are coming when the whole room is in dark. Can you see that? From a small hole, from the window pane maybe, you can see the path or the rays which show some dust particles. Have you seen that, students? Anyone?
Yes,
And,
ma'am.
and sometimes these particles are in movement also. They're coming from top to bottom. So this also shows the movement of particles of gases which are being collided with the dust particles around the environment or present inside the environment. So this movement of certain particles which is happening or which we can see is due to the collision of particles in the environment itself. This was proved by Robert Brown and this motion was known as Brownian motion. So this is the experiment which proved that particles are moving inside the fluid and gases. So you can write, see there is an experiment shown in the screen also. This one only I was talking about. So now you can write about the definition of Brownian motion. They can ask and they cannot ask. It depends on the question paper. So you can write the definition of Brownian motion. Hosan, don't write on the screen, please. Done? Now we will do the second, like the last property. Yes, you can write the effects of temperature as well for the Brownian motion. It will also increase on increasing the temperature, same as the kinetic energy and the diffusion things happen when we increase the temperature. Yes, Fozan, you want to ask something?
No, ma'am.
Okay. Diffusion and Brownian motion are the two processes which provide the best evidence for the motion of particles in water. Okay, so we are done with this diffusion Brownian motion. Now we are going to study about the fourth property of the matter. This is all diffusion, which we have already studied yesterday. So it says in the gases also diffusion happens. We have studied that the gases are also moving from higher concentration to the lower concentration due to diffusion. We have taken an example yesterday, if you remember, that inhaling of oxygen is also what? Movement of gases, movement of oxygen from higher concentration to inside where there is a lower concentration of gas. So this is also be done through diffusion only. Okay. This we have already done, so I am not repeating this one. We are directly going towards the fourth property now. So the fourth property states that the particles of matter attract each other. Now we have already seen this yesterday, no? In solids, the particles are like attracted with each other. They are bonded strongly with each other. Particles of matter attract each other. Okay, tell me this, okay? By this we can conclude how does a particles of certain matter react inside the matter itself, whether it is solid, liquid or gas. So when I wave my hand in the air, like this is air, no, I can easily wave my hand like this. I can easily move my hand inside the air. I do not need any sort of energy or any external source of energy I need so that I can wave my hand inside the air, right? But if I move my hand inside the water, like there is a bucket, imagine there's a bucket filled with water and I am keep on moving my hand inside the water. So will it take more energy in comparison to air or less energy in comparison to the water? What do you think inside the water when I am doing this, moving my hand?
Ma'am, more energy.
More energy. Okay. And if I have the eyes, am I able to put my hand inside it or wave my hand inside the eyes or no? Yes or no?
No, ma'am.
Why so?
Ma'am, because ice is solid and their particles are packed closely.
Yes, closely packed to each other. Great answer, Lavanya. So it shows that every particles of matter are attracted with each other, but it depends. Somewhere the particles are in less, there are less particles and they have more space in between them. And in some situation, in certain solid matter, we have multiple particles which are bonded together. Okay, but attraction is there. One more point you have to know in this property of matter is that liquid also shows the movement inside the okay, there will the point will come, I will explain that one. So in this point you have written this point, no, like this chalk, iron, nail, these are solids, they are attracted to each other, their particles are attracted to each other, and that is why solids are compact in nature. So this is a property of solid that they are compact. Compact is their property which is making the solid to maintain their shape, like chalk, iron nail, ice cube, because their particles are compact. Okay, which is easier to bake, which requires more force. Yes. Okay, so which will be easier to break, students? Among this one, who will tell me? There are three examples given on your board: chalk, iron nail, and ice cube. Chalk. Why so? And which will require more force? Iron nail, right? because iron nail is more compact in comparison to the chalk. It is easy to break the piece of chalk into smaller particles, correct Lavanya? And a cube of ice requires more force, whereas the iron nail does not break even with a large force, right? We need a hammer to, or even we have to like, we can even increase the temperature of an iron nail and melt it down, right? In that way, we are going to put some force, external force on this iron nail. Otherwise, no force can be put. Yes. Okay. Now, this conclude that one more thing which we have to write in this one. First we read it and then we are going to write it. So the force of attraction between the particles is quite weak. The force of attraction between the particles of ice is a bit stronger, whereas the force of attraction between the particles of iron nail is very, very strong. But what is F dot O dot A? What is this force of attraction? Anybody? Force of attraction is what? Or in short, F dot O dot A. Anybody? So everyone, the particles which are present inside each matter, solid, liquid, gases, they have certain amount of force of attraction, which is making all the particles to bond together closely. And we need some external energy to overcome this force of attraction if we want to change the state of certain matter. Getting my point, everyone? Like by giving higher temperature, we are breaking this force of attraction to change the phase of matter into liquid or gas. Okay, so we are actually using the energy to overcome this force of attraction, like high temperature, like giving heat. This one is important. You can write it down as we have done in the same as we have done in the diffusion part, no, where we have seen the diffusion is more wear and least wear. So in the same way, the force of attraction is maximum in the particles of solid matter and minimum in the particles of gaseous matter. You can note this point down. This is a relationship of force of attraction with respect to solid, liquid, and gas. One more point you can write down. The force of attraction and kinetic energy of the particles primarily determine the physical state of a body. Done? All right. So we have completed the four physical properties of matter. So one by one, what was the first one? That particles are very small and are in infinite number, right? The second one, that they have space between them. Then the third one, that they are in
Then,
Hmm? Say it,
then,
say.
then they are moving continuously.
Correct. And the fourth one is they attract each other, right? All right. Only I think Lavanya is only studying right now. Nobody else is in the mood to give the reply. Hmm? Okay. So next part. So this is we have done already. Now, we are going to study the states of matter. We already know different states of matter, but we are going to see certain properties of different states of matter. And mind it, the question comes from this as well. They will ask you the properties of matter. Like they will not ask directly, but the question can come for the reasons. And I will make you practice of those questions. First, we will see what are the properties of different states of matter. So physically, matter is classified into three states of matter, which we already know: solid, liquid, and gases. So this table, maybe they will give you the table. You have to. Okay. Matter can exist into two more states, which we were discussing. That is plasma, super hot gases. The matter which is present at very high temperature like sun, and the Bose-Einstein condensate. So this is nothing, students. Let me tell you in a brief about these two, plasma and the Bose-Einstein condensate. First, let me see in the chat. Yeah, solid, liquid, yes, okay. So in these two, no, what happened, students? For changing the solid into liquid, we are applying higher temperature, right? To melt it down and then it convert into the liquid. Further, when we have to change liquid into gas, we still provide more temperature and then liquid will start showing the vapors out, which we call it as steam, and then that turn into gas, right? Now this gas when is provided with more temperature is given to this sort of gas, it will turn into plasma, super hot gases. Getting my point? It is very short, brief to let you know what is plasma. So, plasma is nothing but the gas thing only, which is kept at a very high temperature. And what happens, when we start giving higher temperature to these gases or the vapors, they get ionized. Ionized is what? They become ionized gas. Ions means electrically charged particles. So, the sun is made up of trillion of gases, which is ionically, like they are electrically charged gases, radiated gases they are. Okay, so plasma is nothing but the ionized form of gas, you can say. Ionized form of gas is plasma. Super hot gases, when we are providing more and more temperature to the gas, that gas will turn into plasma. Okay, so all the crackers fires, you can see the rockets, everything is this plasma state of matter, which is having the hot gases. Now, when we take this gas and provide it with a lower temperature, very low temperature, lower than the 0 degree also, then it will turn into Bose-Einstein condensate. So when we will go higher, when we provide higher temperature, it will become plasma state of matter. And when we are reducing the temperature or taking it to low, like freezing it, that is Bose-Einstein condensate. Everybody got this one? This is a very brief explanation and there is nothing much to study about plasma. Like at this class, there is nothing to study more about it. So ionized gas is the plasma, and when we reduce the temperature in those gases, it will turn into Bose-Einstein condensate. All right. So all these glaciers with the minimum temperature you can see around comes under this state of matter. Okay. So we will see one by one. Okay, I have to remove this one. Artificially created state of matter, which is a very low temperature. Some certain models in which you can see these type of layer, this Bose-Einstein condenser. So there are two scientists. Bose is from India and Einstein is from like out from India. You already know about these scientists. So they both together generate this state of matter, which is called Bose-Einstein condensate. Okay, so we are going to study solid, liquid, gas now in detail because they are in our syllabus. Solid state first. So space between the particles is least. We already know this one. Force of attraction between the okay. you can write down states of matter and then start writing about properties of solid, like solid properties, like this. Properties of matter, number one, properties of solid. So every question which can come no regarding this solid liquid gas depends upon the particles only, their movement, their compact nature, their bonds. So in every reasons you have to like include these all these terms, okay? Must include the particles. So space between the particles is very least, right? We know that. That is why they are not, they do not show the movement. Like they start vibrating up and down on its own position, but they are not moving everywhere because there is so less space in between them. And the next one is force of attraction between the particles is maximum. That is why they are bonded with each other. Every particle. Third one, kinetic energy of the particles is least. Why so? Why the kinetic energy is least? Fixed shape and size and they do not flow. Yeah, correct. Fixed, and the question might come like this. Why does a solid is compact? Why does a solid has a fixed shape and size? So you need to conclude, you need to give the reason, because the particles of solid are close to each other. They do not have space in between them. That is why every particles or every solid is compact. Maintain its shape. Okay, Lavanya?
Okay, ma'am.
Okay. So the third one, the kinetic energy of the particles is least. How and who will explain me this one? Anyone apart from Lavanya? You can also write down the answer. Dhanishri is not there. Is she here or no? Lipika is here. Fozan also. Om used to write the answer today. No one is writing. Bad day or what? Hmm? All right. So kinetic energy of the particles is least, students. Why so? Okay, Lavanya, you can give the answer then. Kinetic energy is low. Why? Because students, kinetic energy depends on what? There is the answer. Okay. Space between them least. Okay, so what will happen, Om, then? If the you are going like you are close to the answer, tell me. If the space will be less, will the car move on the road? There will be traffic jam, right? So, kinetic energy is present only at those particles which can move, which are in motion. Now, here in the solids, nobody is moving. Particles are stuck. They can't move. So, there is no motion, means no kinetic energy. Least kinetic energy, because there is no space. You need to mention this, students. I'm keep on saying these terms. Space between the particles are less. Temperature. How come temperature will increase, Om? We will provide the temperature, then only the particles will get temperature. No, if there is an isolated system where there is no external force, no external temperature, so do you think the kinetic energy will be there in the solids? No, there will be no kinetic energy, because the particles are stuck, they are in stagnant position, they are not in motion. So that is why kinetic energy is less. So you need to mention the answer like this. You have written this one, no? Because the space between the particles is less and it will lead to no movement in the particles, and therefore kinetic energy will be low or least. In this way, you have to explain your answers. Okay. Now the fourth property of solid is what? Particles of solid are closely packed together. They cannot move much. Solids have definite shape and volume. We will complete the solids today because they have their particles are bonded together, that is why they maintain their shape and structure, definite shape and volume. Solids are mostly incompressible. We cannot compress the solid. Why so, students? Compress means what? Compression means what? Yesterday we have learned this statement, this vocabulary. Compressible. Putting pressure. Okay, Alpana. Wow, nice name and new name. Great. So we can't put much pressure on the solids because their particles are so closely bonded with each other. And we cannot break them as well. Like this, the example you can see negligible compressibility. Negligible means we can't do, like least compressibility. Their volume does not change by any outside force. That is why they are incompressible. Third property, solids are rigid, right? They are rigid. Rigid means anyone? There is a opposite high rigidity. Yes, Lavanya. But what is rigid? What do you mean by rigid? Pranit says putting pressure. Correct. Compressible statement you are saying. What do you mean by rigidity, students?
Ma'am, the tendency of a substance to retain or maintain their shape, ma'am.
Okay, correct. But in a simpler form, rigidity, Om said the correct answer means hard. Correct. Like we
And
cannot change. Hmm?
they cannot bend easily.
Yes, which cannot bend easily or which are hard in nature. Hardest even. Okay. Mm-mm-mm-mm. Unbending and inflexible. There are examples. Their shape does not change by any external force. Some solids are elastic, like the rubber band. Now, most of the times, no, you can see this question, students. Why does the rubber band is a solid in nature? Very important question. You can see this question and most familiar question. Why we can say this rubber band is solid? We can change its shape, right? By applying the force. But rubber band does not comes in solid nature. It is in elastic form. It is a property of solid only, that some solids are elastic which can regain their shape when force is removed. Can you give me any other example other than this rubber band? Very familiar example. Anyone? Which can regain its shape and is kind of elastic. Anyone want to put their input or shall I say the answer? How closely packed? How closely packed what? In which respect you are saying, Lipika? Cloth. Lavanya says cloth. Okay, cloth can be the answer. Hmm. But it is solid and it comes under elastic. One more. One more. You know the example of a sponge, students. Sponge. It also can regain its shape, right? So that also comes under the elasticity property of the solid. Hmm. Hmm. It shows. Okay. Also, some solids are plastic as well. You can write this one example, clay and dough, which can break and then take a structure of a new one. Like we can take, but also we can regain that structure, its initial shape, we can regain it. Clay and dough. Okay, so this was all about the properties of solid, which we have done. So one thing you can write more, you can add on with this, with these properties, write this property. Fixed volume. Okay, you have written this one. Okay, cannot be compressed very low. Vibrate in fixed position. Write this property, students. Vibrate in fixed positions. Maximum density, correct. Kinetic energy you have written. Yeah, only these 2 points you can write down about the density and the fixed movement. We are done with the solid property. Now we are moving on to the liquid one. We still have 5 minutes left, so we can start with the liquid properties. Liquid state. So space between the particles is moderate. Oh, if you guys are writing, should I wait or should I move on? So this is the first property of gas, which like the space in between the particles of the liquid is moderate. Not too much, not too far. It's moderate. Okay, Lipika. Force of attraction between the particles is less, obviously. Writing someone, very less rigidity, correct. So that is why, the particles of liquids are in flowing nature. They are flowing. They can pile up. These particles can pile up from one to the other. The third one, the kinetic energy of the particles is less in comparison to gas. Okay, not that much less, but yes. Low compressibility. Yes. Yes, Lavanya. In liquid, particles have moderate distance between each other, so particles can move, right? So that is why kinetic energy is also moderate. You can't say less, but yeah, moderate. Low density, then solid, correct. Liquid state. Also, this property that liquids can take the shape of a container as well. The property, yeah, you can write this one if you don't know about the fluidity. It is a property of liquids that says that liquids can flow. Okay, so this we have done, right? Anything left? Takes the shape of container, more space than the solid, less than gases, strong but not strong enough to hold position, these liquids, and then can slip and slide over each other disorderly because they flow, obviously. Takes the shape of the container, fixed volume, almost negligible compressibility, higher than the solids. Kinetic energy is higher than the solids and can move past one another like the water and oil. Now 2 minutes. Okay, we can do the gas one as well, and then we'll start the new topic from the next class. Okay, there is a question for you. Arrange 4 transparent containers. Place scale in slanting position. Okay. Take 4 different types of liquids. Okay, so now they are going to tell you about the property of viscosity. Do you know anything about viscosity, students? What is viscosity? Okay, can you tell me this, like I have a cup filled with water and I took the ink and just immersed the ink, little bit ink inside the water, and then I have one more cup filled with water and I'm going to put some drop of honey in it. Will that honey is going to immerse or dissolve inside the water immediately or similar to the ink, or it will take time? Anyone? Show fluidity? No, I guess. Yes, yes. Oil will not dissolve properly or it will take time to dissolve inside the water. Why so? Does it depict any sort of property of that oil which is different from that ink? Or honey, sorry, I'm saying oil now. Honey and ink. You know, honey is much thicker than the ink, right? Also, honey is much thicker than the water as well. Water is quite light. So this viscosity is related to the thickness of the fluids. Okay. So from this part, we are going to continue in the next class, students. Thank you all for joining the session and we will meet in the next class. Okay. Thank you. You can leave the session and join the next class.